All right. Welcome to the very first episode of ZwitterCo Unfiltered, real talk on membranes. Now, today we're going to be doing the first of a series on evolution products. And these are food grade products for food processing, dairy, biotech, enzymes, fermentation, etc. But also within ZwitterCo, I'm sure that we're going to have ZwitterCo Unfiltered podcasts covering water and wastewater treatment. I'm John Goodman. I'm the Vice President of Food Processing and Specialty at ZwitterCo. And with me is my colleague, the esteemed Scott Brown. And Scott, why don't you introduce yourself?
Sure. So welcome everybody to Unfiltered. This is going to be a fun, hopefully fun, just a chat between John and I to discuss the things that we're seeing in the field. And we're pretty excited about some of the things that are going on currently and the things that we have coming up. And this will be primarily in the food or specialties realm. But like John said, we will come back, or some of our colleagues will come back with the wastewater treatment and solutions segments as well. But we're pretty excited to talk to you all about the things that are going on in the field currently.
As this is our first episode of ZwitterCo Unfiltered, we want to start with some customer questions that we get. And obviously, we want to make this a valuable use of your time. And so we're going to cover questions that we receive. And of course, feel free to send us questions. We're going to cover some applications on talk about some of the installations where we are, and we're going to have a topic. So the first question that we're going to discuss is one that we've received a number of times from customers, and that is, why is the clean water flux of ZwitterCo membranes, and particularly for protein concentration? We have our PCM membrane, which replaces 10 kilodalton membranes in protein concentration. So the question is why is the clean water flux of PCM lower than a regular conventional polyether sulfone 10K membrane? But while the water flux is lower, on product, the operating flux is higher. And so this is something that we have consistently observed from testing that we've done internally and from customer testing. And as we know in process streams, flux is highly dependent on the gel layer or dynamic barrier layer that forms on the membrane surface during processing. And what we're seeing is a higher operating flux with the ZwitterCo membrane must mean there is a thinner gel layer being formed. And that makes sense because that gel layer is being made up of proteins, fat, other organics adhering to the membrane surface. And because ZwitterCo membranes have an anti-fouling surface, we're having a different dynamic, or the gel layer forms differently, and less shear force is required to move the gel layer off the membrane surface. And so I've been referring to that as comparing it to frying eggs on a Teflon coated pan versus a cast iron skillet. And you get a lot more sticking of the eggs to the cast iron. Same thing's happening here on the membrane surface. The organics, the proteins are sticking to the conventional membrane more than they stick to the ZwitterCo membrane. So you get a thinner gel layer and thus higher operating flux. And we're seeing this all over in a number of different applications and from a number of different customers. Scott, is that how you've been, relating it to customers?
Exactly, John. And the fact of the matter is that we still need that gel layer to get our separation, but it doesn't need to be the way that it has always been. And that's the beauty of this new membrane that we've discovered or developed, I guess is a better term. It's exciting because where we don't need as thick a gel layer to get the separation that we want, it's easier to clean and faster to clean, and we don't need as harsh a chemical to clean. And all these things come into play when we start talking to our customers about how this is all going to work.
And it's very interesting also because in these protein concentration applications, we're, of course, at the front end of the system, there's less of a gel layer, you get higher operating flux. And then as you concentrate up to higher solids, everyone always sees, of course, much lower operating flux. And As far as a percent difference, we're seeing some tremendous differences in terms of operating flux at the back end of systems where it's higher solids. And it's going to be fun to see if we can get enough data to really generate a formula for percent solids on different streams versus a difference in operating flux, so we can truly understand how systems can operate better and more efficiently. Also, I know that you've had some discussions about either going to higher solids or perhaps, allowing people to make some higher value products by being able to flux more.
One of the exciting things is again, this is all an example or a process of viscosity. As the product goes through the system, the viscosity gets thicker. We end up with a thicker product in the back end of the system. Where we have a thinner gel layer and we're getting better passage in the back end of the system. Imagine, if you will, if you've been running WPC 80 forever, right? And you know that in the back of your system, you're getting maybe half a gallon or 2 gallons a minute overall in your whole system, in your whole loop. Now, where we've got that thinner gel layer, where we've got better passage, we can drive those solids, I believe, a little higher without having the low flux. I think that as the flux increases, and we're seeing an increase of flux, anywhere from 50 to 100% increase in our field trials right now. So if we're doing that in the back end of the system, imagine how much higher we can drive your solids and where we can get you. And the things we can do for your dryer, we can increase the amount of product you push through without increasing the size of your dryer. Or we can increase the amount of solids that are coming out of the back of your system without adding another loop or more stainless steel. And these are the things that we're seeing in the field.
So the higher flux, the higher operating flux, and this concept of the thinner gel layer with the proteins not adhering to the surface as much, less shear force required to move the material off the surface. I've also gotten the question, could systems operate at lower crossflow than with conventional membranes? We believe it is possible because of this less shear force required. However, I would caution that, or really with any customer, always try getting into a discussion of how can we save money? How can we create the most value? Generally, where customers can take advantage of producing more product, we always go in that direction because the value created is at least an order of magnitude more if you can produce more product with the same equipment, same people, same overhead. But where you can't take advantage necessarily of producing more product, then we start looking at how we create the most value. You mentioned earlier about the easier cleaning, and another possibility is the energy savings from lower crossflow. Does that make sense? Can that save more money than operating at the same crossflow and getting higher flux, or potentially easing up cleaning? Do you have any other thoughts on that? I don't know if you've gotten that question from anyone.
I haven't gotten that deep into it yet, John, really. And I like the thought of maybe lowering the crossflow. We need to get more data. And until we have more data points, I really don't want to speak to it because I can't quantify it.
Well, very good. Another topic that we wanted to chat about is one of the installations that we have, one of the applications. Scott, why don't you take the lead on this one? I know that you've got a customer you're working with who's treating their seal water from the pump seals.
Yeah, that's a pretty exciting opportunity there. They were struggling. They've been struggling for years. They've reclaimed all of their pump seal water, and they collect it, run it through an RO, and then it is their intent to discharge that water after it's been clean and the permeate is completely clean, that it can go back to the river. And that's an exciting treatment. So it's a good way to recharge the water system, but it's also very imperative that we make sure we keep our chemistry in that water at a level that is better than it was when we got it from the ground. In this application, we're seeing less biofilm in the permeate. That's the exciting bit. In the past, when they had conventional RO elements in the system, that the permeate, when it was collected then before it was to go to the river where it was being treated chemically to bring the pH into the proper realm, they were seeing buildup of biofilm in that whole system. That was requiring excessive cleaning every day to the tank that we collected it in. We were seeing excessive biofilm buildup on the probe to check the pH. That needed to be cleaned a couple of times a day. And since we've installed these elements in July, they haven't cleaned that system once, not one time. And this is the end of November. So if you think about that we've had basically 3 months plus with no biofilm building up inside of that system, it really greatly increased their ability of what they can send to the river.
How has the customer, it must have taken a ton of manpower to have the operators constantly cleaning that tank, and like you said, even the probe on a daily basis or more than once. How are the operators responding on that?
Any of us that have worked in a plant, John, know that as our intentions are great, right? We have intentions to clean it a couple of times a day, but really was it getting done, right? And I think that was the problem. I think there were a lot of times that it would go for days because nobody had the time. When you're busy fighting fires, you forget about the things like that, right? So I think that the buildup was even worse. So I think that the operators are seeing a difference, and the supervisor that's in charge of that bit came to me and he said, "This is fantastic. We haven't had to clean this thing one time since July." That's to me, that's very exciting.
That's great.
And they're thrilled.
I've had discussions with a couple other companies about possibly treating seal water. Have to admit, typically I'm focused on product. I'm not used to having that many discussions on more of a utility water. You've been in the plant. Does every plant have the same possibility from your perspective?
Oh, absolutely. If that was within your realm, if that was part of your KPI, we've got to save water, which has become a big hot topic, right? The thing that surprises me the most, especially about polishers, typically we all feel about polishers, oh, it's just the RO water. It shouldn't be a problem. We shouldn't see any issues with our polishers. And yet we continually see organic film built up in the polishers. And we try to get it out with, sanitizing, etc. But here's the coolest thing is if we don't have to worry about that buildup because it's not sticking to the surface of the membrane, now we can move on to better and bigger things. Another customer, this is in a plant in California, they were struggling with their polisher and they completely changed their whole system over to our elements simply so that they wouldn't have the buildup of the foulant. Now, the elements have not been installed yet, but it's coming soon. We should get more data, but I'm excited to see exactly how this is going to come together.
From your experience, and actually, I don't know if you covered it, the seal water system, what was the cleaning protocol on that? How were they cleaning, and how are they cleaning the ZwitterCo membranes?
So just the membrane system cleaning, they were doing a junk caustic wash, then a caustic wash full on with caustic and surfactant, then an enzyme wash, then an occasional acid wash, then another caustic wash at the end, and then a sanitized daily. And they were still seeing buildup, immense buildup of biofilm on the surface of the membrane. And we couldn't put enough sanitizer in that to get that out. So they were changing those elements every 6 months. And now we're not seeing that. We're not seeing that at all. And we've reduced the washes. We've gone to a caustic junk wash with surfactant, then another full-on caustic surfactant wash. We're not doing the enzyme wash at all. And then we're finishing on a sanitize. And the fact of the matter is they're not having near the issues that they've had in the past.
Which is great. Have they done an analysis of the chemical savings and water savings?
I can't say that we've got a really good handle on exactly how much was saved, but by saving the most expensive wash that we do on any membrane system, by eliminating that enzyme wash, we've come a long ways. I could probably get the customer to give me some information about how much money has been saved, but it's difficult to quantify that.
Yep. And then I'm also assuming they've removed a step from the chemical program. So,
yep, absolutely.
So that must be saving them 45 minutes to an hour.
An hour every day. They're able to get back up on product that much faster. And as the product builds in the tank, the faster they can get it back on product, then the smoother the operation is. They have a less opportunity to lose product. So yeah, at the end of the day, it's been a big win for them and they're excited.
All right, Scott, we got to get a case study on that.
Absolutely.
Well, excellent. Thanks for reviewing that. And
yep.
I look forward with this series of podcasts to be able to do that every time and just talk about how different customers have what they're experiencing.
And to circle back and review exactly what we've seen for the next podcast, to come back and give a review of what we've seen going forward from now.
Sounds good. So let's move on to our topic of the day. For our first podcast, I thought we would do something a little more general, and that is interesting, memorable applications or system designs that you've seen. And and Scott and I, we didn't rehearse this at all. It'll be very interesting. Scott has been in, you've probably been in 100 times as many plants as I have. Scott spent 10 years as a production manager for Glanvia and has worked with Hydrite. He's worked with filtration engineering, Tetra Pak, as well as with Coke membrane in the past. I'm a longtime RO guy, but I've always worked with membrane companies. And so generally, I've been working with equipment manufacturers more from a distance, whereas Scott is got his feet right in the plants.
Literally, and way up my legs and milk all over me, and yeah, I've had all that stuff.
So you start. Tell me one of the memorable plants that you can think of.
There's a lot of really cool applications, and I'm going to get a little nostalgic on you here, John. Okay, just for a second. When I was a kid growing up on the dairy farm in southern Idaho, they didn't know what to do with the whey from the plants, right? It was a byproduct. It was something that it was a nuisance product. And they would literally load it on trucks and bring it out to our farm, and we would dump it out in the field and use it kind of like fertilizer just so that they could get rid of it. But as these plants have grown, of course, then the amount of whey that they produce grows, right? So if we talk about the plant that I was the production manager, and they received 11 million pounds of milk a day, every single day, 365 days a year, which meant I was going to get 9,500 pounds of whey that came through the wall, whether I was ready for it or not, right? So every moment that I could get, that I could shorten my washes or any way that I could get more time, that was always the big topic. Time and yield are the two big topics that everybody wants to talk about, right? So I have seen this industry grow from where we would just get that whey at 6.3% total solids right through the wall, and we would run it through an RO to concentrate it to 18% total solids, and then we'd run that through a UF to make 35% protein to do calf milk replacer. That was the whole idea. It's what we were doing in the late 90s, early 2000s, right? But to have gone from that to where we are today, where we can separate out these proteins and we can concentrate those proteins and we can eliminate the lactose, for instance, we can drive to WPI 90% whey protein isolate, no fat, no lactose, a little bit of ash. That's all that's left in that product, right? So to go from where we didn't know what to do with it at all to where we're making WPI 90 in a matter of 15 years, it's incredible to me the speed at which this industry moves. And again, that's one of the things that I found very exciting about coming to ZwitterCo. Our technology, our ability to flux higher, have less fouling, we can help this industry move even faster, and it's already moving at breakneck speed. It's exciting. And to be able to separate the calcium out and to get a milk calcium stream, to have milk protein concentrate, right? To completely eliminate the curd herders and the cheese step, right? It's very exciting to be able to drive to MPC 85, 87 and use our products. And we're not afraid of the fat. Conventional elements, fat can be very, very difficult. So we're excited because of where this is going to go. Some of the most difficult projects I've ever seen were in nanofiltration, where we're trying to concentrate and squeeze that last little bit of water and mineral out so that when we go to our dryer, we don't have problem with bulk density with the powder. To the layman, it doesn't seem like much, but to a guy that's in the plant, the difference between packaging bulk density of 42 to 51 is incredible, because now we know we can get the powder in the bag. The bags are going to stay on the pallet. They're going to survive transport. All these things are very important. And they're things that are incrementally changing. And if we can go with the SF instead of the NF in those systems, drive out a little bit more of that lactose, increase our solids that much more. If we can take the total solids from 42 to 44 even, the bulk density, it makes a huge difference. It's very exciting.
So it's funny, when I was thinking of the topic, I was trying to think of some of the interesting designs. Do you remember some of the early, this goes back to the 1990s, Some of the early, one of my customers referred to it as a full Mother Nature system. To achieve higher solids in an RO system, they would put NF membranes in the final stage.
Sure, we did that.
And then take the permeate from the NF and put it back to the pure stage.
Yep.
And biggest challenge I remember with those systems were controlling calcium phosphate scale in that NF stage. Are people still doing that system? Because I haven't heard of one in a while.
They are. Matter of fact, I was in a plant earlier this week where they had a mixture of RO and NF elements in the same system, in the same stage. And they're still doing that. And they're doing it effectively. And they're driving the solids harder and higher. Again, the permeate becomes an issue because now you've got more mineral, more ash in it if you have the NF elements, right? But again, we just take that permeate and we put it into a different system. We reclaim all of the solids. And that's one of the beauties, I think, of the dairy industry in particular is we're all very solids conscious. Where do the solids go? How do we make sure that we reclaim every single little bit that we can get and still operate efficiently? So yeah, we have done that in the past. We're still doing it today, like I said. But I think that there are better opportunities coming for us. If we can manage those solids in an effective manner by using the proper elements, I think we can be more efficient. There can be challenges, but challenges are only opportunities, right, John?
Yep. Yep. Hey, you know, it's interesting that you just mentioned the plant that you were in that's mixing RO and NF, because another plant that was very memorable to me was what wasn't in dairy, but it was a different protein concentration. And again, this goes back to the 90s. I'm old. So, you know, I have all these, most memorable, what's that? Well, we're old. Yeah. The most memorable stories I have generally go back to the 90s when a lot of these applications were new and we didn't know what membranes could do. Today, we mix membranes in the same system pretty regularly. Most WBI 90s have 10Ks up front, 5Ks at the end. But one of my first experiences doing that, protein concentration, mixed two different NF membranes. I was working with a customer and they were trying to reduce their protein loss. They wanted to try a tighter NF membrane. We had no data on how it was going to perform. It was a membrane typically used in water applications. Sure enough, put in this tighter NF membrane and the flux went way down. They were passing less ash and that was causing osmotic pressure to go up, causing flux to drop. So I get this call from the plant. We got a problem. You know, our flux is down. What have you got? And basically emptied out the warehouse of all the piperazine, the deashing open NF type membranes and shipped them down to the plant. And they ended up having this blend. And we talked about how do we want to mix them? You know, do we want to just have tight NF at the front of the system? Do we have the other way around where we have the loose NF at the front and the tight at the back? We talked about how to do it. And what we decided to do is just mix them in each stage and mix them in each housing. So everything was balanced.
You mix them in the vessels as well.
Exactly. So that way everything was balanced and started up the plant with this mixture. Boom. It was right on spec. It worked great. And it was pure serendipity.
Well, what we did back then, John, it was all trial by fire.
Exactly.
And I tell people all the time, you know, the best way to get good experience is by surviving bad experience. I got this flat spot on my forehead from beating it on the side of a piece of equipment in the middle of the night. It's all trial by fire. Yep. Everything that we've learned, and I'll guarantee you, everything I've learned has been by the hard way, you know?
Yeah, like I said, you've been out in plants, so I'm sure that you've got situations where customers were having a hard time and you were able to come up with a way to clean their system and save the day that way. My experience has always been from how do we take some theory, you know, how membranes should work and apply it. And you know, I've been real fortunate over the years between heat sanitizing, ROs, and high temperature continuous operation. I still remember back in the old days before we had all the different feed spacers and being told you can't do that with a spiral. I mean, think about how much higher we achieve now in total solids with spirals, when the old thought was you needed a plate and frame. And the economics are just so much better with spirals. And between the equipment manufacturers working with the processors and the membrane companies to come out with these products and figure out how to run them and then figure out how to clean them, the economics have improved so much over the years.
Well, they had to. because the industry has grown. So the prices have gone down. It's efficiencies of scale. We had to increase the size of the plant. We had to increase the sizes of what we were doing, but we couldn't let the costs get away from us. So everything had to have an ROI, and it had to pay back very quickly. And these are the things that we've learned. And I think it's really great, John, that you brought up the synergies between the manufacturing companies and the OEMs that build the systems and the cleaning companies that help to clean the systems and us membrane manufacturers. Those synergies have really changed the dynamic, and we all have to work together. It's been good.
Without a doubt. So, what I'd say is we'll definitely have some different topics that we can discuss over this series of podcasts. And we also welcome listeners to send us suggestions. Hopefully they're all good suggestions and not
and questions, right?
And questions.
I think maybe one of the big suggestions we'll get is if we can get a couple of better looking hosts. How about that?
Yeah, well. I don't know how I come through with the background. I'm not sure if I look younger and prettier with it or not. I think you look great.
Well, I think I look like the business, but I think these are good opportunities for us to come to folks and tell them a little bit about what we're seeing in the field. And I really look forward to the future podcasts because we'll have more data, and the more data we can share, the better off we'll all be.
So thank you all for tuning in and putting up with us. This has been fun to do. Scott and I banter all the time. We'll do our best to keep it professional and like more of a studio setting. However, one of these days we may bring out a bottle of red wine and really
conversation a lot more interesting.
Exactly. So thanks again, Scott, and thanks for tuning in. Look forward to the next time.